Section 1.7, Solving Absolute Value Equations and Inequalities. Perhaps you remember from Algebra 1 that the absolute value of a number is the distance a number is from 0 on the number line. So because it's a distance, it's always going to be a positive value. So the absolute value of x equals 3. So in other words, what number is 3 units from 0 on the number line? So x can be 3 or x can be negative 3. Both of those are 3 units from 0 on the number line. In more general terms then, if the absolute value of x equals k, that means that x has to equal k or x can equal negative k. So now we're going to get away from just the absolute value of x. We need to solve absolute value equations. So inside the absolute value bars, I might have ax plus b, and that equals c. So to solve those, you're going to write two equations. So again, ax plus b has to equal c, and ax plus b has to equal negative c. C and negative c are both c units from 0. Then you're going to solve each equation, and then you just need to make sure that you're checking for possible extraneous solutions. And an extraneous solution is one that does not satisfy the original equation. So let's try to solve some. First example, the absolute value of 2x minus 9 equals 15. So we're going to set 2x minus 9 equals positive 15, and 2x minus 9 equals negative 15. And we're just going to solve both those equations. Add 9 to both sides. We get 2x equals 24. Divide by 2, and we get x equals 12. The other equation, we still have to add 9 to both sides. Remember that the left side of the equation is not changed. We're just changing it to plus or minus 15. So now we get 2x equals negative 6. Again, dividing by 2, we get x equals negative 3. But now let's check those solutions. So we're going to plug 12 in for x in the original equation. Get the absolute value of 24 minus 9. And the absolute value of 15 is 15, so that one works. Now let's try negative 3. Plugging in negative 3, I get negative 6 minus 9 in the absolute value, which gives us a negative 15. But remember, negative 15 is 15 units from 0, so that one works as well. The second example. Oh, the only difference is we have an x on the outside. Don't let that scare you. We're still going to set up two equations, and we're still going to solve them. This time, because I have an x on both sides, I'm going to subtract 4x from both sides. So now I'm going to get 10 equals 2x. Dividing by 2, I get x equals 5. Same thing on the other equation, subtract the 4x. I get 10 equals negative 10x. This time dividing by negative 10, I get x equals negative 1. Again, we need to check our solutions. Plugging in the 5, I can see that I do indeed get 30 equals 30. Plugging in the negative 1, I end up getting 6 equals negative 6. And we know that that's not true. So x equals negative 1 is not a solution, and our only solution is going to be x equals 5. So x equals negative 1 is an extraneous solution. Next we come to absolute value inequalities. So I could have the absolute value of ax plus b is less than or equal to c. I could also have that it's greater than or equal to c. Let's take a look at what this means with a number. If I have the absolute value of x is less than 3, when I take the absolute value of a number, it's got to be less than 3. So it's got to be negative 3, negative 2, negative 1, 0, 1, 2, or 3. If I take the absolute value of negative 4, that would be 4, and that's not less than 3. So the two inequalities I'm going to set up, ax plus b is less than c, and it also has to be greater than negative c. So again, if I were to look at less than c, I could say, well, it could be negative 4, but it can't be negative 4, and that's why it's got to be and greater than negative c. Looking at absolute value is greater than c, again, let's take a look at absolute value of x is greater than 3. So this could be negative 4, negative 5, negative 6, right? Absolute value of those are all going to be positive and greater than 3. And then the same thing with positive 4, positive 5, positive 6, and so forth. So the two inequalities you're going to set up for this one, again, just as it appears, ax plus b is greater than c, or it's going to be less than negative c. So we're actually setting up two compound inequalities. One would be an and one could be an or. Let's take a look at an example. Let's take a look for a second. This absolute value of x is greater than 5 means that it has to be 6, 7, or 8, or negative 6, negative 7, negative 8. So let's just, instead of it's just an x, let's use that. 3x minus 7 has to be greater than or equal to 5. That would be the 6, 7, or 8. Or the negative 6, negative 7, negative 8 is going to be less than negative 5. Again, solving these equations, I'm going to let you go ahead and do the work. We should get x is greater than 4, or x is less than a positive 2/3. And again, if you were to check these solutions, they would both work. Let's try one with less than. Again, if we were to think about x just strictly absolute value of x is less than 10, again, that means that it has to be 8, 9, 8, 7, and also it's got to be greater than negative 10. So we've got to get those negative values. So again, using the 3x plus 5, the first one is going to be exactly as the original absolute value inequality appears without the absolute value. And it's got to be greater. So we're going to flip the inequality and make that number negative. Again, solving both of these equations, you would get x is less than 5/3 and x is greater than negative 5. I would challenge you for the last problem and this problem to graph them. When you come to class, let's check that we have all those graphs correct. A food manufacturer specifies that every family-sized box of cereal should have a net weight of 25 ounces with a tolerance of 1.2 ounces. So we're going to write an absolute value inequality. So a tolerance simply means that it can be over or under by 1.2 ounces. So very generally, my acceptable weight is x, and it has to be less than, right? I can add 1.2. I can be over by 1.2 ounces, but it's got to be less than, actually less than or equal to that. And it's also got to be greater than or equal to if I were to subtract that 1.2 ounces. The only thing that all three of these, or both those ends have in common is a 25. So we're going to subtract that 25 from both ends and the middle. We're going to end up with this inequality. And then if you recall, since x minus 25 has to be between negative 1.2 and positive 1.2, we can write that as an absolute value inequality. Another one, you found that your new winter coat is comfy to wear when the temperature is between 10 and 42 degrees. So we could write that very simply as that. To write this as an absolute value inequality, we need to find how far 10 and 42 are from a common number. That common number is simply going to be the average. So add together 10 and 42, you get 52. Divide that by 2, you get 26. So then 26 minus 26 minus 16 gives you 10, and 26 plus 16 gives you the 42. Again, we're going to bring that 26, subtract that 26 from all three parts. And again, since x minus 26 has to be between negative 16 and positive 16, I can write that as an absolute value inequality. Also note, when solving absolute value equations or inequalities, you must get the absolute value alone before setting up your two equations or inequalities. So for example, you would solve this for the absolute value. So you're going to treat that whole absolute value as a variable in itself. So the first thing you would have to do is add the 8. Then you would have to divide by the 3. And now that you finally have the absolute value alone, you can set up your two equations. So x plus 4 equals 8 and x plus 4 equals negative 8, giving us 4 and negative 12. And this would be the same whether you're dealing with an equation or an inequality. You have to get the absolute value alone before you can set up your two equations or inequalities to solve. This is the last section of the chapter, so make sure if you have any questions on anything from the chapter, you come in and ask questions when you come to class.